Welcome to Cranky Calculus. We do have some AP review we're going to do here. So we have a free response question that has a table. I'm going to give you 6 different things that we can do from here that are very common that happened over the past couple of years in the AP exam to help you prepare for this thing. So here we go. We have a function f, which is twice differentiable for all x with f of 0 equal to 2. Find the values, the values of f prime, the derivative of f, are given in the table for selected values of x. You can look at the table right there. You can see all the values. And again, we're given x, so we're given f prime, and we do have a value of f at 0 only, and that value is 2. Approximate f double prime of 1 using the average rate of change of f prime over the interval from 0 to 2. Show the work that leads to your answer. So all you're going to do for this one is that you do want to show that f double prime of 1 is approximately, and you just show the difference quotient. So this is going to be f prime of 2 minus f prime of 0. It tells us that we're using those values over 2 minus 0. And f prime of 2, we're going to substitute that in. We're going to get 2 minus f prime of 0 is 3, and I got this straight from my table. All over 2 minus 0 is 2. You don't need to simplify, but I will for you. You should end up with a negative 1/2 here. So you need to show the difference and the quotient. For part B, we have a trapezoidal Riemann sum with 3 subintervals indicated by the table. So let's go ahead and do that. So we're just going to integrate from 0 to 8 of f prime using our trapezoidal Riemann sum. So that's going to be an integral from 0 to 8 of f prime of x dx. And that's approximately, so what I'm going to do here now is I'm going to be looking at my values. So my first value I have right here, I have these values of 3 and 2. So the difference from x equals 0 to x equals 2 is 2 times the average height, which is my 3 plus 2. So what I just underlined in red is going to be what I just did right here. Those are going to correspond. Okay? And then now let's go ahead and do plus. We're going to go from 2 to 4. So 2 to 4 has a width of 2 times the average of, now let's go ahead and underline this right here in green. And that's going to be 2 plus 0. And that should correspond. What I just underlined in green. And now be careful on this one, because now we're going to go from x equals 4 to x equals 8, and that's going to be a difference of 4. So 4 times the average of, let's go ahead and underline this now in purple. We have 0 and negative 1. And now what we're going to have from that is we can do some easy simplifying. By the way, if you're on the AP exam, you do not need to simplify it. This is going to get you full credit for everything, but I'll simplify it for you. The first term is going to end up with a 5, the second term is going to end up with a 2, and the last term is going to end up being minus 2, so we're going to get an answer of 5 for this problem. Moving on to the next part, the same prompt, we have to evaluate the integral from 0 to 2 of f double prime of 3x plus 2 dx. This is going to be u sub, because first off, I don't have a function with a 3x plus 2 in it, and when you integrate f double prime, you're going to end up with f prime, and we have values of f prime. So I'm going to go ahead and do a u sub here. So I'm going to let u equal 3x plus 2, and that's going to make that into an f double prime of u, which I can integrate. When I do this u sub, I'm going to get du equals 3 dx, divide both sides by 3, I'm going to end up with a 1/3 du equals dx. So now I can rewrite this as the integral of 1/3 f double prime of u du. Since I changed to u bounds, or u's, I need u bounds. So if I were to substitute in a 2 into my 3x plus 2, I'm going to end up with 8. And if I substitute in a 0, I'm going to end up with a 2. So my bounds change from 0 to 2 to 2 to 8. Now I'm just going to rewrite this and make this look really simple. And now we have a fundamental theorem of calculus question. This is a formula that you need to have memorized. So we're going to spit out a 1/3, and this is the same thing as f of prime of 8, put the prime right there, minus f prime of 2. And now I can just solve by substituting in those values, you do need to substitute these values in. So f prime of 8 I have is -1 minus f prime of 2 is 2. This right here is good enough for me as an answer, but I'll simplify it for you. It should be -1. The next question is, must there be a value of c where c is between 2 and 4 such that f double prime is equal to -1? Now, some might think this is IVT, and I totally understand that, but we're not given f double prime when we have f prime values. Since we have just f prime values, I need to find the average rate of change and see if this works, which is going to end up being an MVT problem. So first things first, we can only use MVT if f prime is continuous and differentiable. So I will say that f prime is continuous on the closed interval 2 to 4. I said closed and I wrote open. And f double prime, let's go with f prime. Overthinking it here. And f prime is differentiable in the interval from 2 to 4, and that is because f is twice differentiable, so you do need to mention that. You can't just assume differentiability, you have to state it, and you can't assume continuity, you have to state it, and that's usually given to us, because f is twice differentiable. So because of that, I can now find the average rate of change and see if that matches our f double prime. So if I find our average rate of change, I'm going to get f prime of 4 minus f prime of 2 all over 4 minus 2. And I have those values of 0 minus 2 over 2, which is -1. So therefore, yes, this does happen by MVT. Do not state out your theorems either, because unless they ask you to specifically, because if you state the wrong theorem, you can actually miss out on a point. So make sure that you answer this yes. People sometimes forget to answer yes. Our last two parts that we have here are on screen. So part E, a particle is moving along a curve of f in such a way that the particle's position function is p of x is to e to the x f of x, where p is the distance from the origin. Find the rate of change of the distance of the particle to the origin at x equals 0. So I'm trying to find the rate of change of p, which means I need to find p prime. P prime of x, since I have a function times a function, is going to be product rule. So I'm going to do the derivative of the first. So derivative of 2e to the x is 2e to the x times the original, plus leave 2e to the x, and then we're going to do the derivative of f, which is f prime. This is product rule, and again, the e to the x's are the same because the derivative of e to the x is e to the x. So once I do the product rule here, I want to find this at 0. So I'm going to get 2 times e to the 0, f of 0, plus 2 times e to the 0, f prime of 0. E to the 0 is just 1, so I'm going to end up with 2 times f of 0, which is 3. Or this should be f prime. Oh wait, hold up here. Hold up. I have f of 0. F of 0 is up here at 2. Plus 2 times 1, which is just 2, and then f prime of 0 is 3. So if I add those together, I'm going to get an answer of 10. So we got to be careful, make sure that we use our initial condition, which is really important for our next question. And this is a BC only, so if you're not taking the BC exam, you'll not see this, but for BC kiddos, this is a pretty straightforward question from a table. Use Euler's method starting at x equals 0 with steps of equal size to approximate f of 4. So if we're using equal size steps, I use that as delta x. It might change in x. If we're going from 0 to 4, we have, with 2 steps, x is going to equal 2 because we only know values of 0 to 2 to 4. So I'm going to first approximate f prime of 2. Okay? So actually, sorry, not f prime of 2. I'm going to approximate f of 2. I can do that by looking at the previous step, which is f of 0, plus the derivative of the previous step times the step size, which is 2. When I do that, f of 0 is 2, that was given to me, plus f prime is going to be 3 times 2. So f of 2 is approximately 8. So now I can use that to approximate f of 4. So this is going to be f of 2 plus the derivative of the previous term, times the step size, which is 2. So f of 2, which I just approximated as 8, plus f prime of 2 is 2 times 2. This is going to end up being an answer of 12. So f of 4 is going to be approximately 4. Do not forget to like and subscribe for more content to help you study for the AP Calculus exam.